Ladies and gentlemen, welcome to the Ryan the Ride Mechanic channel. How the heck are you doing today? I am Ryan the Ride Mechanic. You probably guessed it judging by the intro, right? I did, right? Today I want to go over electrical stuff. By that I want to do a little bit of learning today. So I wanted to go over some relays, latches, and things like that. So today I'm going to play with some high voltage. Well, not quite high voltage, but I mean, well, let's play with wall voltage. Well, wall voltage here in the US. Not over in Europe, but close enough. Let's get into it.
Now get ready. Here we go.
First of all, welcome back and thank you for watching another video. If this is your first time here, subscribe. Why? You'll find out later. Don't worry about it. So I wanted to do some things today, and we're going to build a couple of electrical circuits for you. Basically, I'm going to use some parts and pieces that we might find on some rides, maybe some controllers. Not quite sure yet what this video is going to bring, but I just wanted to start playing with some electrical here and see kind of where it went. It's not going to be the whole video. I'm going to be talking at you. I'm going to be working mainly here on my desk building some things, so you won't see much of me this video, but I have a feeling most of you are like, yeah, that's fine. Get off the video, we don't care anymore. So let's try some stuff. Okay, so I've got an idea. Why don't we, got a light bulb base. I'll get a light bulb. Why don't we turn the light bulb on with different various methods to do it. The first of which we will use a regular light switch like you have in the house. This would be considered a normally open switch. Turn it on, change the state. Back off. Let's wire this up real quick. Got a light bulb, and I've wired it up on the bottom. 2 wires. Light bulbs work by we just take wire and put current in one side, goes through the element in the middle, comes back out the other side. So we're going to switch this up, and we're going to use a switch to turn it on. I've marked the switch top so I know which way is on, which way is off. Now, it's important on these guys to know that this is a normally open switch. So, which means that it's off state, or it's down state is off in this case, but it's also a maintained switch, so we can leave it on and walk away. That's different than what we use on rides and most equipment. We use something like this. This is a switch base right here that I got from a piece of equipment, and basically has 2 contacts on the inside. One's normally open, the other one's normally open. So we basically just push down on that and it turns the signal on. Release it and it turns off. So the fact that it's normally open means that when there's nothing pushing on it, it's open. Well, this one's same here. When you push it down, it makes contact, and when you release it, it's open. Some switches, when you release them, they close. Those are called normally closed contacts. So we have a normally open contact, and then a normally closed contact. If you've watched my other videos on relays and stuff, that would be these symbols right here. These relays right here have, let's see, 3 normally opens and 3 normally closed on them. So we're going to take this. We've got our bulb wired up now. We have our switch. Hopefully the bulb's good. Should be. Down the off position. So now we have to wire this up. So here's our cord coming from the wall, and my disclaimer now is that I've been doing electrical for a long time. I wouldn't say I'm trained in it, but I've been doing this quite a long time. So the most important thing to realize is that anytime you're dealing with voltage, especially wall voltage, it can be deadly every single time, because it doesn't matter the voltage through it, it's the current that kills you. And you only need, I believe it's 500 milliamps to kill you. So, and that's the point where, like, if you were to grab a hold of this wire and you get electrocuted, it's not the fact that you touch the wire one time that kills you, it's the fact that as soon as you touch that, your muscles contract, and now I can't let go of that wire. And if that is going through my arm, could be going through my heart, and then it could be causing my heart to fluctuate and possibly stop. And then the entire time that's happening, that path of electricity back and down wherever it's going out is literally being cooked from the inside out, like a steak. So electricity is not something that you just mess with if you don't know what you're doing. So when I run these demonstrations and stuff like this, I want everyone to just know, like, the age-old, don't try this at home, because I know what I'm doing, so I prefer nobody else try it if you don't know what you're doing. If you do know what you're doing, then you probably know what I'm doing already. So I'm going to go over some basic electric concepts, some basic rules of thumb, but this is not by any of the means in-depth theory to these parts. So I know if you're one of those guys out there that has the in-depth theory of how this stuff works, it's like, I'm not covering that stuff. I'm just giving people some basic analogies of what's this and what's that in the video. So let's move on. So first we're going to do power in and power out. Typically I like to do things flowing from top to bottom, so this is the top here. So I'm going to go ahead and put my hot wire here on the top and then screw that guy down. I know if you're an electrician, you're like, man, there's so many different ways you can do this, and there is. But again, we're just going for the basic idea here. Nothing fancy. So I'm just going to do the bare minimum. Sometimes I might even use jumper or alligator clips to do this. And then to continue on, because I know my black is hot power, so I'm going to use the black wire. One of them has a black stripe on it. I might give that just a little bit of a bend to stay on there, just while I tighten it down. Alright. Okay, I've got that now. So I now have power coming from, it's going to be the cord, again right now, unplugged. So I'm going to have power coming from the cord, comes through this terminal, but it can't make it to this terminal until I flip the switch. And then hopefully, assuming the light's not burnt out, hopefully the light turns on. And then I'm just going to take these two guys right here, put them together, and just use a rough wire nut to hold them. And then that will be that. I will go ahead, just because I have the ground, I'll go ahead and secure the ground, just so it's not a loose wire hanging out there in the open. Okay, so now my connection's done. I will set this here. Now this is very important to realize that these are exposed electrical connections. Like if I plug this guy in, if I touch this, I can get electrocuted. So I am not going to touch that guy at all. I'm going to leave him right there while I plug this in. In fact, I might even barricade it a little bit up. I'll just take something heavy and set it on top of this so it doesn't move. Wunderbar. Yeah? Yeah. Take my extension cord here and plug it in now. Okay, so now power is hot. I can't touch anything that's been wired because there's US here. There's 110 volts going through this. And again, it's not the voltage, it's the amperage that kills you, but I know for a fact that this plug has 15 amps behind it before the circuit breaker trips. So what we're going to do here is we're going to take this guy and see if we can turn it on now. And it works. Simple circuit. Power is running through, comes back to the neutral right here. That's the one that I wire nutted together. And then back out the cord right here. Okay? So you can maintain the circuit, stays on. Turn it back off. Okay? Unplugged it. See? We're dead now. And one of the things I like doing while I'm working with this stuff is I like to leave the plug out in the open where I can see it. That way I know for sure it's undone. All right, so now what I'm going to do is I'm now going to use the switching base, and I'm now going to take this guy out and put the switching base in its place. That way you could see the reaction of a normally open switch, just like you would have on one of the rides. It's a momentary push button, essentially. So we're going to leave the neutral wired up because that guy can stay there. We don't care about that now. Okay, we've got that switch out. And this was a leftover from another project here. So, if I look in here, I have the brown is the hot wire coming in. So that means my brown, which is this guy right here, is going to go to the black wire. Twist those. And then I put a wire nut on it for safety so I don't accidentally touch it. Okay, and then I'm going to use one of these two switches, in which case it's like, I'll just continue on with the black wire right there. And just because, now the white wire is coming off of this switch right here. I don't know how well you can see that. It's coming off of this switch right here. So I'm going to use this one, but it could also be that one. So that's a branch. And I'll show you a branch circuit here too, along with this, because, ouch, man. No, it wasn't a shock. It was a little piece of copper that got jabbed in my finger. Yeah, copper strands sometimes suck to work with, because they could poke you, and it hurts. Alright, going to use more wire nuts here because this is now considered, even though it's not pushing a button, it could be considered live power. So I'm going to go ahead and cap that one too. Okay, now we have our brown wire hooked up to the hot, and our black and white wires, our black wires hooked up to the bulb. White wire is back onto neutral, so again our circuit is going to go through the button, through the bulb, and then back out the power. So we're going to connect this. Okay. Keep this up here for safekeeping. Alright, so now we are going to test, and because that's a little bit liver than I normally deal with, I'm going to use my fluke tool that I love, and I'm going to push on the black contactor. Bulb turns on. As soon as I take it off, bulb turns off. Now, yeah, I can do it there. There's a little more room for error with these buttons, so it's like, whenever possible, I like to use non-contact stuff. Okay, so this is a normally open circuit. Notice it says push it on, turns on. As soon as I let go, it turns off. That's the way the majority of stuff is in rides. That's not safety related, and I'll get into that in a second. Those are normally closed functions. So I'm going to make one wiring change, and I'm going to show you a fork in the diagram. Wiring. Unplugged. Set that down there. So now, see? So now what I'm going to do is I'm going to take apart my hot wire coming from there. And I'm going to attach that white wire. Remember there's two buttons here? I'm going to attach this white wire to it. Now, look at how this behaves now when I put it together. Plug this back in. There we go. So now what I have is I have the black wire, just like we did. It's going to be on this button right here. We're good. And now the white wire is also in there. So now you can do the black or the white. It doesn't matter which one it is. On a ride, think of this, not to see what a good explanation would be, but let's say this is the unlock restraints button, right? So I can put unlock restraints from the main panel, and it The bulb turning on would signify the restraints unlocking. But the secondary sitting at the back of the station can also push the same button and it would do the same exact thing. So this is just a fork in the circuit. But when I energize this button, it backfeeds power to the bottom side of this button as well too. So it's not a very safe circuit, but it is a standard circuit. It's like, okay, now what happens? Let's get rid of these buttons altogether for carrying 110 volts through it, and say we're going to be operating in a wet place, and now we want to use a relay to do the same exact thing. There's a couple different ways to do this. The easiest way is to use a relay like, yep, this one. This relay runs its coil, internal coil right there, runs off of 120 volts. So this is the same voltage as all of this other stuff. So unplug it, test it. Okay, so now what I'm going to do is I'm going to undo this and I'm going to put this relay in its place. So now there's a couple things we have to deal with when it comes to relays. The relay also needs a neutral because it's kind of like a bulb. It's got to have power go in one side and come out the other side in order to turn on the electromagnetic coil on the inside. So we use that on two terminals on here. They're typically called A1 and A2. Sometimes they might just be classified as a pin, like this one right here. It just shows, you can't see that, I know, but there's a little wavy symbol between the relay, and that little wavy symbol means the coil. So that's between those two pins right there. So now I'm going to wire this in with that in mind. So I'm going to do the hot on one side and the neutral on the other side to power the coil, but that's actually going to be coming from that button. So now we start needing more wires to do this stuff typically. So we have our hot coming in right here and coming out right here. So I'm going to have to add another wire to this. So I'm going to take this all back apart. Okay, so I've got to add some more wires to this guy. So I've added another wire right here to the black power, and then I'm going to wire nut that back together. So now I still have, it's going to come out on these two right here, which I'm going to cap both of them for right now. Okay. And then I'm going to take the black wire, and that wire is going to go around to the top, and that's going to be my feed. That's going to be the branch feed for the circuit. That's actually what's going to go through the relay to the bulb. I got to take my white wire now, and I now have to hook it up to what's going to be the A2. The A2 is going to be this guy right down here in the corner. That's going to be my A2 right there. And now, from the switch up here, from one of these switches, let's use the, I'm going to use the black wire right here. From that switch, that black wire is now going to feed the coil for the relay. So I'm going to stick that guy in there. I hope this comes out on the video stuff because, man, this is, it's intricate work and I can't really have the, you know, everything, because even if you could see close up on it, it's a jumble of wiring. That's kind of how electrical stuff always is. So let me cap this guy off because that's it. Okay, so right now we have power coming in here and branching off. All right, it goes through the cable to the switch. And then it goes through it's going to go through the switch, and it comes back here to this coil. When that switch is pushed, it will go through the coil and come back to the neutral, and it will tell this coil to pull in and energize. I'll lay the coil on its side. Hopefully I can get a video of it. I use my phone. Hopefully I can edit the videos together. Okay, so I've got that. That's already there. Now nothing's going through to the bulb yet. The bulb is still not plumbed into the circuit. I simply just am going to be testing the function of the coil. Let's get this guy plugged in. Okay, and then I should be able to energize this guy right here. And I don't know if you could hear that on the video, but what I'm doing is I'm energizing the coil, and it's making those contacts jump up and down. So those contacts are just another switch right here. So if I get my bearings on this video, there we go. So right now that contact will be energized, and when it's like in this state, power is going through this upper contact right here. Electricity is going to go from here, through here, and out that pin. And then when I push on the relay, tell it to turn on, now power is going to go through this pin, down to this pin, and back out the other side. So let's go ahead and wire the rest of that up. So this is also one of those reasons why it's like, oh, you ever wonder why stuff is down for so long? Because this is just turning a light bulb on with the circuit. If you can imagine thousands of relays working together. Okay, wiring diagram here. Might as well use my other video camera for this again. Okay, wiring diagram here, as you can see, there's the coil on it right there. So there's my power and my neutral that I'm using. And then when I went ahead and hooked up, where is the base? There it is. I went ahead and hooked up that pin right there, which is going to go right there. And I want this guy, when it triggers, to go to that screw right there. So where that is on here is actually right here. It's pin number 1 in that case. They try to draw these things to where this diagram matches up with the layout. Here's the key indicator right there, which is that little notch on the bottom. So now I'm going to wire the hot light of the bulb. That guy is going to go to pin number 1 now. Okay, I'm going to put the relay back in, like that, right there. Okay, I'm going to take this guy, plug it back in. Okay, now what I'm going to do is that I'm hot with power now. So now what power is doing, it's coming through here, it's branching off to everything, it's going to go through the button. The button is actually just turning on the relay. That's all the button does. And then the relay is allowing the higher current electricity to pass through this wire, out this one, to the light bulb. So now I am pushing a button, which is turning the relay on, which is allowing power to flow through to there. There we go. Same exact thing. Okay, understand? Now, where this really comes in handy is when you use bigger things, larger current draws, because I can now use a smaller voltage to drive this assembly. I can use 24 volts. Like I'm in a wet area and I just want to use 24 volts DC. I can use 24 volts to turn this relay on to power a 200 volt 40 amp light, whatever I could put through this relay, that'll do it. This one right here, let's see, what is it? This guy, oh, this guy is rated for 10 amps at 120 volts. So I could run almost a full circuit of this electrical cord through this relay safely, and it will sit there and do it all day long. Gonna unplug now. Okay, so on rides, when we do stuff, we say, let's dispatch, and we push the button, or let's open the restraints. Let's do something like that. We push the button, and whatever it is maintains itself. It turns on and holds, like we did with this switch originally. We turn it on, and it would just hold itself in that position. So what we did there was we built a latch. Now, this stuff, let's see, I don't have another 120 volt relay handy to do this. So you know what? I'm going to have to pause the video, and I'm going to have to work in now a 24 volt power supply. Okay, I have added now a more complicated setup to do the same thing. But this is much more realistic to what bigger equipment has and what it does. So what I've used now is that I have now my 110 volts coming in here, and this is a power supply right here. It takes 110 volts AC and breaks it down into 24 volts DC. Most things in the automation world run off of 24 volts DC because it's lower, it's safer, there's much less risk around it. So DC is typically used, smaller intervals, lower voltage, that sort of thing. So what I've done is I brought my 110 volts in right here. Show you that. I can't, hopefully I could zoom in on the video. I'm sorry about that if it doesn't come out great. But I'm using, and my neutral is branching off, and it's going to the light bulb. That's what we're still working with. And now my hot branches off, and it comes right around here, and it goes down into pin number 1 right here on the relay base. And then it will pick up, once the relay is installed, in pin number 3 right here on the other side, and continues on to there. Now, for control of the relay, here is my A1, which is the black wire, that guy right there that we're using, which is coming from this guy. And here's the brown wire, which is feeding the circuit, which is coming from the 24 volts positive. And the 24 volts negative, which is this wire right here, comes around and goes to the A2. So I have 24 volts positive that's going to go through the switch and come around to A1, and that will energize my coil, and then it goes out A2 and goes back to negative. When the contacts change state on the inside, right down inside there, when those contacts change state, they will allow power to go from pin number 1 to pin number 3 and through there. So let's plug this guy in. I'm going to energize. Okay. Power supplies are a little more, this type especially, are a little more dangerous to deal with because this is all open right now. It doesn't have a cover on it. It's meant to be inside of a cabinet, which it's not right now. So my biggest concern here is actually these capacitors, which could pop just because of their age. This is all stuff out of old equipment that I've salvaged over the years because making little circuits and stuff. So okay, so I've got my 110 volts live into here. The bulb is still off here. And then I'm going to go through and hit the black wire with this guy right here. So when I push that guy down, I'm now using this relay to let 110 volts through the relay on the relay. So what was done in the last one is now I'm using 24 volts to control the relay. I'm using 24 volts to control 110 volt. So this is something like use on motor starters and things like that. We just use 24 volts to control a 480 volt motor starter to run booster wheels or something else like that, something that might need to start and stop. But you notice, like, it still doesn't do me much good because it only works while I'm pushing on the button. So next thing I want to do, bear with me, is I now want to make a maintained latched circuit. And that for that I'm going to need both these buttons, and the latch circuit is what we're going to use to make a stop-start circuit. This is how most everything works on rides. You hit the button once and it latches the circuit on. You hit the other button, it latches the circuit off, or turns the circuit off. So this is that's going to be a very, very common thing. So I don't know, maybe I will break the video and speed it up and leave it running. I'm not sure. Trying to deal with all these things. Okay, so now here comes the fun part with power supplies. Watch this. Huh? Did you hear that relay click? That relay clicked once more before the capacitors died on the circuit board, and then it wouldn't let anything else happen. But had 110 volts still be on this wire, I would have turned the light on for that one click afterwards. But it's not. So I'm unplugged. I've hit it a couple times and held it. That should drain the capacitance out of that board, but I'm still going to treat that stuff with much respect. Alright, now what I'm going to do is I'm going to wire in another relay, and things are going to get weird. So here's what I've done. So I've now taken 24 volts, an extra tap, off of the transformer, this power supply, and now I've run it through here, and it's going through another contact, and it's going to go from here to here, 6 to 7. 6 to 7 on there shows that it's normally open, so while the relay's in there, it can't go through here until this relay is turned on. Once this relay is turned on, the power goes through here, it goes through this relay, it goes from 4 to 1. Assuming this relay is off, power goes through, comes back around to the A1 again, and creates a circuit. So as soon as this relay closes the first time, it energizes itself and holds itself on. And then the way you stop that is using the stop button, or this white one over here, and this will open this relay up, which will break that circuit. So let me show you what that looks like. Take one, plug this in. Okay, we have power. So right now I could use the black one right here. I'm going to use this button, so my big hands. Okay, I could use this guy. And the relay function over here. And now this relay playing with it for an extra second. The induction's causing the board to light up over there. That's interesting. Okay, back feed through the electrical. So now you notice that light did not turn on at all. See, right there. That's because this is the stop circuit. This one's stop, this one's start. So now we're going to press the start button like we would to dispatch a ride, right? Ready? All clear? Dispatch. But I'm not touching anything now, see? So what's happening is that command went to this A1 and said, turn this relay on. As soon as it did that, that voltage went through through this relay now, through this one, which is a stop relay, and went back around to the A1 on this side. So now it is holding itself shut. The current is constantly just going like that. It's doing this figure 8. And then as long as this relay is in, remember, the light bulb works, which is not a big deal. So this would be like the ride is running right now. This is like every ride running circuit out there is this. It is held in. And then a stop, emergency stop, ride stop, anything like that is this button over here, which is the white button. And we push that guy now. The light turns off. So this is exactly how a ride start-stop circuit works. You press start, it energizes this relay, which is being looped through here, and as long as this relay is intact, you do that. I know, say, well, what happens if you can't push the button to that, if something happens with the relay? So you could take this at any point in time and remove it and stop the latch. Now, if I put this back in, it won't restart because the latch is broken. So you have to restart the latch manually by pressing the start button. See, start and then stop. And start, stop. This is basic electrical stuff that any mechanic that has to work on roller coasters, rides especially, should know this, because this is, I mean, I don't care, almost any ride you go to has these circuits all over them. The smaller, the more kid-friendly the ride is, the more of these circuits you find. When you move up into bigger stuff like major roller coasters and things like that, they use logic controllers. But this circuit is built digitally inside the logic controller. So the circuit's still there, it's just digital instead of physical. But you know, almost everything, including major roller coasters, has e-stops, which are the exact same way. The e-stop circuit functions the exact same way. In the morning time, let's say this is your e-stop circuit, and this is not ready. See, the light's not on. Say my e-stop circuit is dead. And then you go, okay, so you go through and it may have you check e-stops and push them down and up, so the PLC gets its inputs and outputs and says, yes, that's good. And then at the very end, you go, okay, we're going to hit the ESR reset, emergency stop relay reset. And when you do that, you press the reset button, and assuming all your e-stops are up, the e-stop circuit is now activated, and the e-stop circuit is waiting for a command. It's waiting for it to be broken. So the ride could be in operation, everything's going fine, then we have something like guest jumps in infield, boom. We drop the e-stop circuit out. Now pretty much on major roller coasters and a lot of rides, every circuit in the ride almost runs through the e-stop circuit. So power distribution for sensors, motor controllers, all that stuff, sometimes even the shunt, the main incoming power to the ride, is held on by this e-stop circuit. And at the end of the day, when everything's all said and done and all those things are reset, the e-stop circuit's active, ready to go. Think about e-stop, ride stop, whatever you want to be. Or you could also be a ride running. And then we say, tell the ride to stop. By the way, on most rides, like smaller rides, roundabout rides that just sit there and spin, the operator hits the ride start button, the ride runs. It's typically a timer in the background just counting down that's holding this circuit open. You can push the stop button and get it to stop, but the timer will automatically, it'll go 5, 4, 3, 2, 1, and then the timer automatically drops it out. So you can have lots of these things wired up in series with each other, which is one of the reasons why relay logic is so hard to troubleshoot. Because think about this mess right here, and you're like, oh my gosh, this is so complicated. Well, think about this now, but having 50 of these relays in a chain with each other. Some of them have to be on, some of them have to be off. It all depends on where the ride is and what state of time. That makes things super complicated. The newer equipment, you don't really have so much of that. It's all in here, but it's the same thing inside of here. It's just digital. It's not physical, it's digital at that point in time. But it's the exact same thing. That's why once you learn relay logic, you could learn almost anything at that point in time, because this stuff is all how the entire ride functions. I think that's going to do it for this video. If you haven't already, please make sure that you like and subscribe. If you want to see more stuff like this, let me know. This is the stuff, like, for the majority of my job that I was doing, I was a controls electrician. This is the stuff that I worked with all the time. So I have this stuff. It's simple. I love to make this sort of video more often, but honestly, I'm limited by the stuff that I can get a hold of, because I can't get a hold of a lot of this stuff that I was using inside rides and things like that, because they're super expensive. Let me give you an example. They're so cute when they're tiny. This is an inductive proximity sensor. This is a barrel or pin proximity sensor. I don't have any of these left over from rides. I kick myself at the amount of stuff that I did not keep as an example, because most of the stuff I dealt with, even if it was intermittent, it went straight in the trash can. I never kept it. But like these sensors, these little tiny ones, I can buy them on Amazon for, I think these were like $10 a piece. But one of the full-size ones that lines a track out there on a ride, those guys are about $250 a piece, $300 a piece, depending on the type that they are. I've seen little pin proxes like these guys that were also $300 a piece, incredibly expensive. So when I want to make videos about this sort of stuff, I have to be careful, because I have to go out and purchase all of this stuff to make the video. So maybe that'll be my next video. We'll work with pin proxies and stuff like that on the next video. All right. I'm Ryan the Ride Mechanic. I hope you've had fun. This was entertaining for me, so I hope you like it as well. Have a good evening, good day, good night, wherever you are. And remember, as always, stay off the air gates. Bye.